Welcome to the Explainer. Today, we're taking a journey from the ground right under our feet all the way to the edge of space. Why? To get to know our planet's invisible shield, the atmosphere.
So think about it. What's the one thing that stands between us and, well, the brutal emptiness of space? It's something we're in every single second of our lives, but we hardly ever see it. It's the very air we breathe, it's why our sky is blue, and it's the shield that makes all life on this planet possible. You see, Earth is wrapped in this deep blanket of gases. It's our life support system. But here's the thing. It wasn't always here. Nope. For the first billion years or so, Earth was a totally different and much more hostile place. So that begs the question, how was this incredible, life-sustaining shield even built? To answer that, we've got to travel way back in time. It's a story of fire, water, and eventually the first tiny sparks of life itself.
This was an absolutely epic, multi-billion-year process. So first, picture early Earth, a chaotic volcanic world. These volcanoes were just constantly erupting, spewing out this thick, hot soup of gases like water vapor and CO2. Then, as the planet finally started to cool down, all that water vapor condensed and it began to rain for centuries. This formed our vast oceans. And then came the real game changer. Tiny microbes, cyanobacteria, started doing this cool new trick called photosynthesis. And in the process, they began pumping out oxygen, completely transforming our world into the blue marble we know today.
So now that we know where it came from, what exactly is this atmosphere made of? Before we start our ascent up through its layers, let's take a look at the ingredients that make up the very air all around us. You know, it's really easy to think of the air as just, well, air, but it's actually a pretty complex mixture. You've got gases, you've got suspended water droplets, and you've got tiny little solid particles. Each one of these plays a super critical role, so let's break them down.
The gases in our atmosphere pretty much fall into two main camps. You have the constant ones and the variable ones. The constant gases, like the name suggests, they don't change much. But it's the variable gases, the ones that exist in these tiny, fluctuating amounts that often have a huge outsized impact on our climate and weather.
So get this, a whopping 78% of the air you're breathing right now, that's nitrogen, which is essential for plant life. Then you've got 21% oxygen, which, we all kind of need to live. But it's what's hiding in that tiny little 1%, especially those variable gases, that has a massive impact on our world. Let's take carbon dioxide, CO2. Even though it's a super small fraction of the air, it basically acts like a planetary thermostat. It traps heat from the sun, which creates the greenhouse effect. And that's what keeps Earth from being just a frozen rock and makes it a perfectly habitable temperature. And another one of these vital variable gases is ozone. High up in the atmosphere, the ozone layer acts like a global sunscreen. It absorbs the sun's most dangerous ultraviolet, or UV radiation. Without it, that radiation would just scorch the surface, making life as we know it completely impossible. And we can't forget the other key ingredients. Water vapor, that's the fuel for all our weather. And dust particles, little bits of salt, smoke, ash. They're not just junk, they are the microscopic seeds that clouds need to form around. And they're also the reason we get to see those beautiful red and orange sunsets. These are the real unsung heroes, the architects of our weather and the artists behind our skies. All right, so we know what our atmosphere is and we know what it's made of. Now let's buckle up and start our ascent, taking an elevator ride right up through its distinct layers. The atmosphere isn't just one big, uniform block of air. Oh no, it's actually structured in 5 distinct layers, kind of like a planetary onion. Gravity holds most of the air close to the ground, so it gets thinner and thinner the higher you go, until it just sort of fades away into the vacuum of space. Our elevator's first stop is right at the bottom. So our journey begins right here, in the troposphere. This is the layer we all live in. The air you're breathing right this second is troposphere. It's our home, and it's where you'll find almost all of the atmosphere's stuff. We're talking about 80% of its total mass. Every single cloud you've ever seen, every storm you've witnessed, it all happens right here. The troposphere is just this zone of constant churning and mixing. And as anyone who's ever climbed a mountain can tell you, it gets colder the higher you go. If you've ever been on a plane, you've traveled right near the very top of this turbulent layer. Okay, we're climbing past the tops of the clouds now, and we're entering the stratosphere. Up here, things get surprisingly calm, and the temperature, well, it does something totally unexpected. It reverses. So why on earth does it get warmer up here? Well, remember that protective ozone layer we talked about? This is its home. As all those ozone molecules absorb the powerful UV radiation from the sun, they release that energy as heat. And that means the higher you go in the stratosphere, the warmer it gets. A complete flip from what happens down below. We're climbing higher now, entering the middle layer, the mesosphere. Think of this as a critical protective zone, our shield against all the cosmic debris that's constantly raining down on Earth. You ever wonder what a shooting star really is? Well, this is where the magic happens. The friction between incoming space rocks and the air particles in this layer, even though they're really thin, is enough to incinerate them into those beautiful streaks of light we see. And after all that heat in the stratosphere, it gets incredibly cold here. How cold, you ask? Try negative 90 degrees Celsius. That's about negative 130 degrees Fahrenheit. It is colder than anywhere on Earth's surface, even colder than Antarctica in the dead of winter. The very top of the mesosphere is the absolute coldest place in our entire atmosphere. Just when you thought it couldn't get more extreme, we climb higher and reach the thermosphere. The thermo part is a big clue. The temperature skyrockets again up here, blasted by intense solar energy. And all that energy creates one of nature's most spectacular light shows. We're talking, of course, about the auroras, the northern and southern lights. These absolutely stunning displays of light, these shimmering curtains of green and purple, dance across the polar skies. And it's all a direct result of our atmosphere interacting with the harsh environment of space. But how does that happen? Okay, so here's how our atmosphere becomes this cosmic canvas. The sun is constantly streaming out charged particles, something we call the solar wind. Earth's magnetic field acts like a funnel, guiding these particles toward the poles. When they slam into the atoms and charged particles, or ions, in the thermosphere, they get energized and they light up, causing the atmosphere itself to glow. So from the air we breathe down here in the troposphere to those distant, beautiful auroras in the thermosphere, you can see the atmosphere is this complex, layered, and honestly fragile system. Every single component, every single layer is connected, all of it working together to make our planet a living world. And that leaves us with a final thought to consider for our shared future.